Uh, Uncle Ben in Spider-Man has said, with great power comes great responsibility. But in the world of infrastructure, we have with great business growth comes great system instability. Uh, if you have questions like what will my system be able to handle the 10x growth, uh, will it be able to scale and perform well even after there is a huge business growth? uh, if these are the questions that are in your mind, our next speaker Arti is going to give a talk about it. Arti has an 17 years of industry experience, and she is passionate about performance and scalability of systems in large enterprises. She has been responsible for building, scaling, and enterprise architectures. And she has given a lot of efforts in scaling high volume data processing pipelines for radio telescopes and creating recommendation engines for retail. So let's hear it out from Arti. Arti, over to you.
Thanks, Sagar. Am I audible?
Yes.
All right, let me start sharing. I hope this is visible.
Yes.
All right. Yeah, let's get started. Yeah, so in one word or in one line, if I have to describe about myself, I'm passionate about building highly scalable and reliable systems. The agenda for today, as Sagar mentioned, is to have a glimpse of business growth because we are talking how DevOps professionals can enable business growth. What that growth means, what are the challenges in that growth, what is the dependence on the IT system, right? And how do we really build highly scalable systems? What practices are needed in order to do this? We introduce the concept of performance ops, and then we describe the method, how to embrace it in your organizations. So let's quickly take a look at the business growth, right? Now, growth is something that everyone aspires, right? All the businesses aspire. And every year during Cyber Week, online sales reach new records. You might have already seen these news. The trend hasn't even hindered during the pandemic. Here are some numbers from the Cyber 5, the 5 days after Thanksgiving this year, 2022. Black Friday and Cyber Monday pulled two biggest daily revenues this year. You can see the numbers here, $9.12 billion on Black Friday and around $11.3 billion on the Cyber Monday. Now, what is important to note here is that if we compare this with the average day in the October, right, on the same year, 2022, then Black Friday sales were increased by 221%. And we are talking about online sales here, right? That's a huge surge. And notably, this revenue increase was not just due to inflation, because we all know inflation is high, but it is also because of the higher demand in the market. And another metric of business growth is Flipkart's Big Billion Days sale. It was witnessed around 1.6 million users per second. Though we are talking about online commerce here, we all know that this also suggests that when we purchase something online, it indicates a demand surge for the other linked and online businesses also, like for example, digital payments, supply chain, retail, electronics, everything. Particularly this year, these were the major sales that happened, which contributed to the 221% growth compared to the normal or average day. So for a business person, this definitely means that this underlines the importance of Cyber Week from revenue, opportunity, market share perspective. But for us, software architects, developers, what does this mean? 1.6 million users per second. It's a huge number, right? And intimidatingly huge, actually. So obviously, the underlying systems that fuel these businesses need to be able to serve that load. And if we look at, yeah, have you seen this? Common? Most often this happens during these busy days, and it's not rare, especially when IT systems undergo unexpected load, right? The Cyber Week is also not an exception here. And if we look at industry reports, right, what did we observe during this Cyber Week? This is a common thing in Cyber Week, not just this year, but year after year, right? Outages, slowdowns, they hit dozens of retailers during Cyber Week. And this is not just a problem for small retailers. You might think that, okay, if a business is small, they might not be prepared for that good. Take Amazon or take Flipkart, they are already prepared for it. Well, they are, but it is not that they will not experience these kind of issues. Walmart, Office Depot, all had issues this year, right? And in fact, some of those, like Office Depot, faced outages for 3 hours. And even the other 40 retailers faced outages this year, which was, by the way, lesser compared to last year. Last year, 50 retailers faced it. So if we look at this number, it seems like a nightmare for businesses, right? These 5 days of the year. And just to remind, this was while handling 221% scale in demand, right? To get things going smooth at that kind of scale is not trivial challenge. And at this scale, many things can go wrong. It's not one thing, right, that can go wrong in this case. So what could go wrong? One is, even if, let's say, the site is not down completely, at this scale, it is possible that the system slows down. Pages are taking time to load. End users have to share or they have to look at blank screens for a long time, right? And they might lose their patience. And it increases the probability of users dropping out. And we all know nobody likes slow pages, right? You and me also will not shop on a website that is very slow. And since different discounts are offered during these Cyber 5 days, everyone is eager to tap onto those discounts, right? And hence, if the site is slow, we'll go to some other website. We'll go to some competitor's website if that is faster, performing better during these busy days. So Google did some research around this. And they found out that if the response time goes from, or the page load time goes from, let's say, 1 second to 3 seconds, with that minimal change, there is the possibility of users dropping out increases by 32%. And if it goes up to, let's say, 5 seconds, then the possibility increases way up to 90%. So 90% of your users dropping out, or the probability that the users will drop, increases by 90%. This happens because your site is slow, right? People could abandon your site permanently, saying that, okay, I tried it during Black Friday, it was not working, I'll not use it for the entire year. Maybe I become loyal to some other e-commerce vendor, right? And for software professionals, the impact of 3 to 5 seconds, probably the 2 seconds increase may not be that obvious. But for businesses, it means a lot, because customer loyalty, customer conversion, revenue, everything is at stake, right? And it is not for an hour or two. They have to sustain this scale for entire Cyber Week, right? 1 week. We saw the number of every day, right? Starting with the Thanksgiving and others. So this is a huge potential revenue impact for them. And if we look at this is not just a revenue impact, but this overall has a link to the business success itself. So digital businesses, online businesses are highly dependent on the success of their IT systems. If systems fail, businesses lose money. They also fail at times. And if systems work smoothly, yes, the business has a chance to grow. Now let's look at let's look at what are the 2 key challenges that we saw here. We saw that, okay, the site can be down, which means there is an outage. It could not scale, scalability challenge. We saw that the site was not loading properly. Again, it was a performance challenge. Now, what is performance? What is scalability, right? There is a very subtle difference. Usually people get confused and they feel that both are the same, but there is a subtle difference in that. Performance particularly is the ability of the system to meet the needs of your users. Users want it to be loaded faster. Users want it to be responsive enough. And also the system should function within the given set of resources. Scalability, on the other hand, means if the demand grows, the system should be able to work without affecting its performance, right? Very, very slight difference, that scalability in turn needs performance. And without both performance and scalability, your system cannot be robust and reliable, right? Let's look at what is the cost, right? If we don't look at scale and performance, we also saw some of the numbers. We also saw 40 retailers went down. So what was the cost? In general, the cost that was estimated was around 10% of the revenue is lost if the business cannot scale. And per minute, Gartner and other industry research firms have come up with numbers that if your site is down for 1 minute, you may lose around $5.6K. If your site is down for, let's say, hour, according to a 2020 research, the cost of that is 300K. And it is billions. If you look at the total unplanned downtime during the year, it is 1.2 billion. Now, it's not just about money as we looked at it. It's about the revenue. It's about the reputation in the market. The businesses will lose the market share, right? And opportunity is lost because it's just those 6-7 days when the business opportunity is there. And the productivity of the IT systems, productivity of the people who are supporting all of these underlying systems of the business, that also goes down. There is a high chance that the business will also lose talent, right? Now, what are the potential causes, right, that this happens? Usually this might happen because of unexpected load, but even if, let's say, the load was predicted and expected, maybe there is some inadequate design that has gone in, which resulted in poor scalability, poor performance. Maybe testing did not happen. Maybe some optimizations were pending, it went into a tech debt, never made it to production, right? Now, there could be many unknowns also. Sometimes you don't have proper observability of your system. You don't know what exactly went wrong. So the site was down, but you couldn't respond to it. We saw the example. It took 3 hours for the site to come back and respond, right? They had to extend their sales for another day. Now, it could also be possible because that there were some hotspots, there were some bugs, but those either were not known or they could not be fixed. Or maybe there was a DDoS attack because the behavior of the system changes orders of magnitude with the increasing load, right? So there could be unexpected problems also during the DDoS or any kind of expected load also. There could be externalities. Your DNS went down, your network went down, or the data center itself had few outages here and there. A lot of potential causes. Some are controllable, as you can see here, and some are not controllable. So how do we really build highly scalable systems, right? Given that this has so much of cost per minute, per hour, we have seen it. How do we really build scalable systems here? Now, there is a belief that if I want to have a scalable system, let me do performance tests. And this is a general belief. You need performance, you need to test it. Now, when do we test performance? Build a system, put it to performance test, run a few test scenarios, identify if there are any bottlenecks, fix those, retest it. Now, and after that, deploy it. But after deploying, what expected load or expected or unexpected, what amount of load it has to survive is something that is slightly agnostic here. Sometimes it is communicated, sometimes it is not. So having performance as an afterthought after building the system, then subjecting it to the performance test and expecting that it will work under any load or any circumstance in the production is not something that is going to work, right? So the reality is performance testing is reactive. It is very limited in a sense that it constrains itself to test the already built system under different conditions and identifies some bottlenecks. It is not that it is not useful. You will be able to identify some bottlenecks, resolve those, but it wouldn't give you the guarantee whether it works for the goals that you set out for, right? And that is where a proactive and holistic approach for performance and scalability is required. And that is where, rather than performance testing being the sole focus, we need end-to-end performance engineering. Now, that means we need to build the system from scratch, right? And when we build it, maybe it is possible that you are actually having a system which scales, but you need to further have 10x growth from here. We have had clients who had that kind of request where some businesses would want to go, let's say, 2x during next year. Some might want to go 10x during next 5 years. So if you have an existing system, you cannot say I need to build it from scratch, right? It is there, it is out there. But what we need to do is we need to work backwards. We need to proactively look at what are the goals for scaling for this particular system. What is its as a state? And how do I ensure that I bring in the performance aspect and the required SLAs as the goal right from the beginning, right? Shift left approach, wherein the scalability has to be the primary consideration. Architects, designers, QAs, operations personnel, everyone has to work in collaboration and build or change the system to make it work for the desired goals, right? And it's like this. Everyone is working. Architects are working for their own goals. Developers are working, designers, QAs, everyone. But if you ask yourselves, even in this room, if we ask ourselves, what is the SLA for my system? What kind of requests per second am I set out to build for? What is my requirement? What are my other non-functional or cross-functional requirements? We call it CFR, right? And what is the kind of reliability that my system needs? What is the kind of responsiveness that my system needs? If you ask these 4 or 5 different people in the same team, probably you might get different answers, right? So the goal itself is perceived differently by each one. While the businesses might want to scale and be able to support the highest peak load during the year, the architects, developers, or even ops personnel probably do not have the idea of that scale, that subtle difference between 5 million and 8 million, right? That could be possible. And that is where we suggest that the holistic approach has to be to shift left and have performance as the focus throughout the life cycle. First thing we need to do in this case is to understand and define what are our cross-functional requirements around the responsiveness, around the scalability, around the availability, how many nines. We generally measure the availability in nines, right? 99.99%, 2 nines, 3 nines, 4 nines. What is that goal that we have set out for? And having that requirement clearly articulated and communicated is important. Now, once that goal is set and everyone is aware of that, everyone needs to work together to define what changes are needed in the architecture in order to support that kind of load or that kind of CFR characteristics. How do I design my system in order to meet those goals? What are the code optimizations? Today, I'm probably changing code. I'm making some API calls to the external system. Will that scale for that kind of load? Instead of 1 API calls, I'm now making 4. Will that scale for 1.6 million users per second? Right? I think those are the considerations that need to go through that the developers, designers, QAs, and deployment teams need to go through when they are doing their day-to-day BAU job, right? And particularly here, when we say shift left, it is not just for the sake of developers and testers to do shift left. Usually shift left means people will think that, okay, while coding, I have to be aware of it. While doing testing, I need to be aware of it. But it is needed to look at the requirements from beginning and also see whether my architecture supports it. If I'm saying 1.6 million users per second, what does that translate to? While this is one CFR, right? But do you know what activity does a user do? What are the critical paths that every user goes through when he comes onto the site? And what is the request per second for some of the key APIs? Not all the APIs will have 1.6 million requests per second if there are 1.6 million users. So which are those key critical APIs that need to handle higher load? What is that number for each of those APIs and how do I scale those APIs? And it's not just about APIs, it's also about the user interface, because the user experience itself is so important. When I'm designing for it, how do I ensure that the components on my mobile screen are only as much needed so that the load time is not much for my mobile screen? So there are multiple such aspects, right? And when we do testing, can I do testing for the required numbers early? I don't want to wait for, let's say, 1.6 million users or testing for these kind of users until production. Can I get a production like test environment, which will not only have data at that scale, but also have traffic for a similar scale, and I should be able to test my application early and frequently. Typically in the agile development process, we see different sprints, different iterations going on, right? So we need to decide the frequency of, okay, when do I do my automated performance tests for responsiveness? When do I do my load test, which will test for the ultimate peak of the year load? And when do I do my endurance test? Now, endurance test, we'll see what those test types are. But different kinds of tests, what should be their acceptable frequency, and when they should be those tests should be done. How do I ensure build after build, release after release, my performance is not getting degraded? Those are all the considerations that we need to make in our holistic approach. Now, when I'm talking about these, we talked about the first thing to be done in performance engineering is to understand what are our cross-functional requirements. And some of the examples are how quickly should my application respond to the user request. Maybe we figure out that it should request within, it should respond within X milliseconds. And it should handle, let's say, X users per second or Y requests per second. And it should work as expected under any conditions, even with, let's say, X number of server failures, 5 server failures, 7 server failures. Availability should be 4 nines, whatever it is, right? So we need to first define that, what is that X is, what is that Y is, right? And capture all these, and also understand what kind of matrix are required in order to analyze, diagnose, and fix any problems if we see it at this kind of load. Now, if you look at this, we are actually talking about performance, scalability, reliability, availability, observability, which is also a concern of the team that actually operates or manages the system in production. So there is an overlap between what we need to do in performance engineering to achieve that scale, that performance, versus what the operation folks are also required to look at. Right? So on one hand, when there is an overlap with the operations folks, as we see, it is not possible if you build any system, if just you do performance engineering and operations, you will be able to scale to that load. No. So the kind of considerations that we talked about that the development team has to go also has an overlap on these things. Right? So basically everyone, the development team, the performance engineering team, and the operations team, all are geared towards, all are set out to have the goals of these CFRs. And hence, there is an overlap between these goals and the need for collaboration to ensure that these goals are met with collective efforts, right? Shift left and shift right. There has to be a combination of both of these approaches in order to do that. And so we saw that like a couple of years back, when people realized the fact that the development teams and operations also need to work together, we called it as DevOps. And we say, okay, DevOps is required now. Everyone has DevOps, right? But for building highly scalable systems, we also need performance ops. So the performance engineering team, as we saw, also has to work with dev and operations teams to ensure that the performance is delivered. Right? Now, what is perfops? When we talk about perfops, is it just a different name that we are giving, just like DevOps? But if you look at DevOps, the arena of things that the DevOps engineers have to do and the way they need to collaborate with the development teams, all of that was so huge, but we couldn't perceive it before really DevOps started. Right. So similarly for perfops also, there is a huge amount of work that has to be done in collaboration with all these folks. Now, what is that? Right? What is that method through which we can achieve this performance or performance ops or perfops culture? Now, there are a set of practices that need to happen. And if we look at one by one, some of them we might be doing as of now also, and some of them might need a slight direction change when we talk about it. So architecture and design guidelines, right? We usually have some guidelines, right? Every organization will have some architecture guidelines, some design guidelines, but those have to be reviewed. Those have to be reviewed in wake of the required performance and scalability goals. Can I have a data model that is, let's say, unstructured, right? Can I have a data model, or can I have, let's say, coupling between my systems? Can I have asynchronous calls, or can I go for synchronous calls? Where do I need caching, right? All of these things have to be relooked at from performance and scalability angle. And that's where I said some of these things we already do, but we need to apply a different lens when we build highly scalable systems here. Now, we also need to ensure there is a lot of automation, because a lot of things when we say we need to do code checks. Now, why code checks? There might be 50 APIs that get called when I am ordering on, let's say, any e-commerce website. And if I say that the architecture, design, and coding guidelines have to be followed everywhere, can I just blindly believe that, okay, my developers might have taken care of that? No, I need some automated code checks there. So either I can go for dynamic or static, or also we can leverage some of the CI/CD build pipelines. There are tools that help us, like for example, Jenkins has performance plugins. There are other APM application monitoring tools that also integrate with Jenkins, and we can have some of the code related checks also incorporated in our build pipelines. And if some of the guidelines are not followed, we can fail the build pipeline. In terms of development also, when the developer is doing any working on any story, the definition of done itself has to be revised when we talk about building a scalable system from ground up. Any feature that is developed, any story that is developed, the acceptance criteria should include these CFRs. Usually, right, 99% the acceptance criteria only include functional aspects. Your feature should be able to do blah, but it doesn't, we haven't seen acceptance criteria. Not many people talk about, let's say, okay, your page load time should be 5 milliseconds, or your page load time should be so and so. Nobody talks about that. So that culture has to come in. Yeah, and as I said, why these are a set of practices and culture. There has to be a lot of automation and tools need to be used in order to enforce those practices and bring in that culture. As so for testing, we already mentioned, right? Jenkins has different plugins that allow you to do not just code checks, but you can also run performance tests, lightweight performance tests, or you can also do load tests during a build pipeline. You can trigger them whenever you want, right? And automated result analysis and reporting is also possible on top of the CI/CD tests and the reports that come out. Now, this is the shift left approach, right? We are talking about what needs to be changed while building the system. Now, we also need to think about, okay, while after the system is built, what are those practices that we need to follow, right? When the tester has already has tested the system and now it is being handed over for, let's say, deployment and all, what are the other practices that we need to take care of? Benchmarking your system is required, right? We always say, right, you can't fix something if you can't measure it. So it is similar. So if you don't know how many users per second are you able to support in as is state, you don't know how will you reach the 1.6 million, just as an example. And from your current state to your expected state, what is that gap and how to fill that gap? You won't know that unless you do benchmarks, unless you do performance baselines, right? So that baseline performance has to be established, and you also need to test it release after release, so that you are aware that, okay, last week we had this number, this week it has changed. Let's figure out which feature actually changed it, right? So you don't need to do post-mortem. You will be able to know how the trend is changing, how the performance trend is moving. We will look at each of these aspects in detail. We also need continuous monitoring and observability to understand what is happening inside the system. Only when we know what is happening inside, we'll be able to fix that. And one of the most important parts is, again, bottleneck finding and resolution, right? Where are the performance bottlenecks? If yesterday my page load time was, let's say, 1 second, and today it has gone up to, let's say, 1.5 seconds, what has contributed to it? Which graphs show me the difference? Maybe there is not one graph, there are multiple. We need to look at that. And how do I, having done all of this, now I have fixed my, let's say, development or building process. I've also fixed my, let's say, operations practices. Now, how do I make sure I still don't have to do firefighting, right? I don't want to respond to an event after it happens, but with all this observability and all, I need to be able to predict that, okay, my response times are going higher. It was 3 milliseconds yesterday. Today it is, let's say, 6 milliseconds. What is wrong with my database? Let me figure it out. Although my acceptable limit for database could be maybe 10 milliseconds, but let me figure out what is happening. So that is the kind of proactive prevention that we need to be able to do it. That is what we call as shift right. Now, slightly double clicking on some of these aspects, right? What do we mean by performance ops during architecture and design? As I said, some of these considerations, testing and development related consideration, we already know, and people are aware that, okay, you need to develop, you need to code for optimization. But what are those architectural and decisional considerations for performance? Right? So when I say I need to support, let's say, 2000 users per second, how does that translate into what APIs per second, right? What API requests per second it is. What is the request per second for APIs? Maybe login may not be as frequently called an API as, let's say, product search. If product search is called, let's say, more often, checkout may be slightly lesser, but it is always higher than login. So we need to know API wise, right? What are those hot paths in the user journey? And what are those APIs that will be able to support those hot paths? And if I want to scale the system 10x, what are the areas in my system that I need to focus on? I cannot say all my APIs need to scale 10x, right? There will be certain APIs that are key for scale up of this journey and user journey, and I need to focus on that. Now, while doing that, what is the architectural style that we need to look at? Maybe we already have some architecture, right? We already have microservice architecture. Let's build on top of it because that is the buzzword. Everybody is talking about it. Doesn't work. You need to think about how much of a trade-off you can do between a particular architecture style and the performance characteristics that it has. If you do microservices, yeah, sure. This is not to say that you won't be able to scale, but the fact that if you have a batch job in a financial system that does reconciliation, you cannot say I will do a microservice for it, right? You have to look at what are the essential characteristics of that particular system and accordingly choose the architecture for that particular system. Now, architecture is one thing, but let's say I want to do 1.6 million writes per second because I have 1.6 million users. Can I use RDBMS? Probably not. So what kind of underlying language, underlying framework am I trying to use here? Will that scale? People always have this question around, will my database scale? Because that is very obvious question. Stateful systems are hard to scale. But less often do we think about, okay, will the JVM also scale? Will the underlying framework, even if let's say I'm using JVM, will the underlying framework that I'm using, will that scale? Will the library that I'm using, let's say for some calculations, will that scale? So those are all the things that we need to look at. And what could be a potential bottleneck? We can also think about it. As I said, database, very obvious. People will predict that actually database will not scale. But what are the other aspects of my system that are probably, maybe there is an external API call that takes 10 seconds. Will that scale? No, right? Will, or probably it will. It is just about figuring out what could be potential bottlenecks and sorting it out by ensuring that the people responsible for those systems are also aware of the needed scale, right? Maybe 1.6 million users per second on my system only translates to 200K users or 200K requests per second for that external API call. So all that mathematics we have to sit down and do and figure out which part of the system needs what amount of scalability and what is in our control and what is external, right? We also need to understand what capacity, what servers do I need to use. So I remember for one of our clients when we were talking about processing a batch system that needs to process millions of transactions per second, there was a discussion around, okay, can my on-prem server scale for this, right? So capacity planning also has some constraints. Sometimes clients cannot leverage cloud. Usually there is a myth that if you are cloud enabled, if your architecture is cloud enabled, you will be able to scale. But underneath, if you are unable to, let's say, go to cloud because of the fact that there are some limitations in terms of contractual obligations or from compliance perspective, how do you ensure that your capacity on the on-prem side is also equally scalable, right? It might involve cost also. And capacity planning has to be done right because it has direct investment from the customers, particularly if it is on-prem. So given all of these constraints and all of this, what are the scaling options that I have, right? Can I do vertical scaling? Is that possible on the on-prem? Can I do horizontal scaling? What is my limit on horizontal scalability on the on-prem servers? Cloud, of course, we do not have that limit, but probably we have a budget limit on cloud. We need to think about those scaling options also. And in terms of making the system highly available and ensuring that in case of externalities where the disaster happens, right, it's not under your control. What are our plans? How do we make automatic failovers to the DR sites? So those are the considerations for, let's say, the architecture design. But even during development, right? As I said, if you ask a developer, what is the, let's say, maximum users per second that you need to support, hardly he will be able to answer, right? And that's a reality. The reason is that that is not our day-to-day language usually. And that is where the need for perfops comes into picture, that everyone, including architects, designers, developers, QAs, and operations folks, need to be on same page around what their needs are, what their goals are. Given these CFRs, and what is the impact of this code change that I'm making here. There is a very, so there was an incident where one of the Amazon developers actually mistakenly added one character to one of the scripts, and that resulted in the whole S3 going down, right? So there are incidents, not just Amazon. I mean, this story will be there in each of the, or every scalable system will have some stories like that. So we need to understand what is the impact of this, and that's where we cannot leave it to the developers. We need to do some automated checks also on top of it, and encourage your developers to think about the alternative approaches, right? Not just following the guidelines, but also thinking about what approach can I take? What is the bigger complexity, let's say, of my code that I'm writing here? If the requests go from, let's say, 100 to 1,000 users, what will be the impact on the current code, right? And what is the bigger complexity here? Can I figure that out on my local machines, right? As a developer, I would not like to wait for my build to be running in the CI/CD pipeline and failing there because it is not performed. How do I ensure it locally? You have tools. You have tools that will do profiling for your application. That will be, you will be able to use some tools locally to do performance test, load test on your own machine also. And keeping an eye on the key metrics of your part of the system. Like maybe as a developer, I'm just responsible to maintain, let's say, one part of the system, let's say just the product search, or another developer is just responsible for maintaining, let's say, the shopping cart. So for this, so for whatever functionality of the system I'm responsible for, what are the characteristics and how does it, like, how do the current metrics suggest me what is the state of the system in order to meet those expectations? Now, quick look at what tools can we be using, right? We have static code analysis tools like SonarQube, and we can also do dynamic analysis. We can do profiling. We can also have some of the observability on the already existing functional tests that happen in the CI/CD pipeline. Jenkins performance plugin is also available. We can also do ELK stack can be used to parse the logs and traces, and also get the matrix for the different errors. Or maybe you have an architecture guideline that, okay, a particular API, let's say payment API needs to interface with, let's say, external systems. And here, to ensure that the latency introduced by our code is not higher, and we don't do much of introduce much of delay here, let's say we need to limit the number of SQL calls that happen to, let's say, just 4, 5. But let's say there is a new developer that came in and added more API calls there. We should be able to spot that. We should be able to monitor and track that metrics and do it, catch it early. Similarly, not just for the sake of, particular developers, or for the sake of checking the compliance of the codes, we can also do real performance tests, small scale performance tests on the Jenkins environment through performance plugins. And we can do benchmarks. We can observe trends, how the response time is degrading or improving build after build, release after release. And if we see that it goes beyond a certain limit, we can also make the build fail, which kind of gives us a quality gate for the performance and scalability. Right? And while I use the term performance, as I mentioned earlier, performance is key to scalability and resilience. But you can also have separate load tests, separate resilience test and endurance test, which can also be integrated into the build pipeline. And yeah, while we do all of this, and we might also be building monitoring, right? As we say, we want to know, and only then if we know, we will be able to fix any problems. But while we have so many metrics available to us in the monitoring and observability platform, sometimes, or typically what we have seen is in larger enterprises, all of these metrics go unnoticed at times, right? Unless there is a problem, people do not have time to come and look at it and correlate it to the extent it has to be. in general, if we look at monitoring versus observing, right, monitoring is quite a reactive, or rather monitoring limits itself to known set of metrics and detecting known set of problems. But if you look at observability, it actually encourages us to look at different outputs, different metrics coming out of the system and inferring what is happening inside the system by looking at this. In a way, it is like a doctor looking at a patient, right? The patient is showing some symptoms. All of these graphs are actually the symptoms. And depending on this graph, you need to correlate the symptoms and figure out, okay, what may be wrong at a given point in time. Let's say we see the response times going very high, error rates going very high. We don't see any other anomaly in any of the, let's say, graphs. But maybe there is one small graph there somewhere in your observability platform, one matrix somewhere available, which shows you that, hey, your database is already very overloaded. And although the CPU usage on the database is not very high, but because you had so much persistent load on the system for, let's say, 7-8 hours, there is a lot of analysis and vacuum backlog in your database, because of which you have too many dead tuples. You are unable to respond to the write requests in time, and hence your write latencies have increased, right? So you need to be able to correlate all these different metrics. The more metrics you have, the more work you need to do in order to analyze it by yourself, and that is where the skill of observability comes into picture, which is very, very critical for performance and scalability. By the way, observability does not have to be, or this kind of ability to see the metrics of this system does not have to be there only in the performance environments or the UAT. It can also be available in your performance test environments and in your regular environments also, for you to subject them to some of these kind of workloads or situations at times and be able to see what exactly happens. Like, for example, if I have the same observability stack on my local also, because we have Kubernetes, and if I subject my system to equal load, I may not be able to subject it to, let's say, millions of users per second, but I can definitely subject it to, let's say, few thousand users per second, and I'll be able to see what is the trend in the behavior. Maybe the scale of behavior will not match. For example, the amount of writes that I'm able to do on my local may not match the amount of writes that happen in the performance environment. But I can actually see the trend as it goes, as the write latency goes high. And I can say, okay, if the write latency is becoming twice, 2x increasing in my local environment with this amount of load increase, obviously in performance test environment, obviously in production environment, when the load is high, it will increase very fast. And this is where I'm predicting all these practices and metrics are actually enabling me to predict what might happen, right? To be vigilant about it and to prevent what might happen. Maybe I go ahead and I fix the vacuum problems, and I ask my DBS to monitor it more frequently, or I set up a practice of ensuring that the database is vacuumed every so many hours during the busy period. Maybe that is not required during the regular load period, right? So those are all the points about observability. Now, having done all of these measures, right, you will still have problems in production, not just production, any other environment, because you cannot predict all the situations, right? And maybe incidents happen. After the incident happens, what do we need to do? First thing is that we need to understand that every system will have some or the other bottlenecks. When you tested it, we tested it with particular load. Maybe that load was matching what was your expected CFR or what was your expected load. You didn't see that problem in the performance test or load test environment, but still the problem occurred in the production environment. The reason for that is there is a combinatorial explosion of what things can happen. And maybe the current incident signifies one of such combinations. And if there is a problem, we need to acknowledge that my system can have bottlenecks. We can't say, nobody can say for any system that there is no bottleneck in my system. Every system will have bottleneck. And some will be obvious with the limited set of test cases and combinations that you try. But the fact that there is a combinatorial explosion, we may not be able to prevent it, or we may not be able to predict it. But when that happens, right, how do we identify the hotspots, or how do we identify the real bottlenecks? Very simple guesses are maybe resource is a bottleneck, very, very trivial guess, right? CPU is a bottleneck, memory is a bottleneck. But then the complexity of the diagnosis goes high when we see that, okay, resource is not a bottleneck. So what are our clues? All the graphs show that resource is not a bottleneck. Then kicks in the observability part, because your metrics are not showing, your monitoring is not showing you any problem. Now you need to think about, okay, what is the bottleneck in my, is there a bottleneck in my application code? Is there a bottleneck in my database? Is there a bottleneck because of the external environments? Let's say, for example, I'm using a third-party load balancer, or I'm using an external CDN, or I have a slow network, right? So multiple things we need to check and identify those bottlenecks. Once it is identified, there are options. We need to think about what options are available. Maybe you need to do vertical scaling, horizontal scaling. Again, very trivial cases, right? Vertical scaling or horizontal scaling. Usually, like only 5 or 2-3% of the problems during scale may be related to that, because you have already planned for the capacity, right? Most of the cases, it will be either your application related, database related, or the external environment related problems. How do you optimize it? How do you actually figure out what that problem is? You need code instrumentation also for that, to enable to, in order to spot the application related problems and also fix it. And yeah, database optimization, stateful systems. Database is just an indicative term here, but any kind of stateful systems, right, are hard to scale, and you need to figure out how do you really tune those to be able to meet the required demand. And yeah, it is not easy to identify bottlenecks, but it also needs sound knowledge of technology. It is not hard also when we say it is not easy. If you have sound knowledge of the underlying technologies that are being used, and if you are able to correlate the matrix, the symptoms that are being shown by the system, and if you are able to, let's say, make sense out of it, you'll be able to definitely identify. And this is not one person, right? We are talking about a whole team of architects, designers, operations, developers, everybody working together in order to find out what the bottleneck is. Yeah. And finally, the mantra here is know what you are building and build it well. One, we need to know the underlying system well. An example is Formula One drivers. It is said that Formula One drivers are able to drive so fast. Like, what is so special about those drivers? It is said that those drivers know the system, know the car, know the metal very well, compared to like other drivers who just use it for their own limited purposes, right? And that's where they are able to use it, tune it to the required speed that they need. Martin Thompson is a very well known figure in this area, and he says, although he has given it a different term, mechanical sympathy, which usually implies close to metal, but the underlying fact is it is not just metal, but it is understanding the underlying system, whatever system that might be, software, hardware, networks, knowing the internals of that system to be able to scale it and become a better developer. Yep. Open for questions. No questions? Feel free to reach out on this email ID also in case you have any questions.
That was great to know, Arti. Thank you very much for such an insightful and interesting tech talk on how performance ops can help architects and us DevOps engineers. It was great to know in depth.
All right, thank you.
Okay, so
I think my Zoom bar has frozen.
I think someone has asked.
Arti, there is one question for you.
Mhm.
Can we scale RDBMS or not?
Yes, we can. Scale is a very relative word, I would say. We need to define what is the level at which we want to scale it. And definitely it is not that RDBMS cannot scale. It depends on what kind of workload you have. It depends on what kind of access patterns you have, reads versus writes, and how are you tuning your system, what is your underlying hardware, how are you even integrating, or what kind of client do you have in order to send requests to your RDBMS. So there are multiple factors involved in scaling any system, not just RDBMS. I mean, it's a misnomer that RDBMS cannot scale. In certain situations, RDBMS will perform or scale lesser than, let's say, NoSQL databases, particularly for those particular kind of combinations, right? But you can very well have higher scalability for your RDBMS as well.
There's another question for you, Arti. What are the resources in AWS which we cannot scale?
Well, I would say there are no resources that cannot be scaled. Every resource or every system has its own limitations. I mentioned it in one of our slides, right? Every system has a bottleneck, or every system is designed for a particular scale. And AWS components, for example, they come with very good documentation of what amount of load or what amount of responsiveness can they support, right? If you talk about databases particularly, the kind of scalability that DynamoDB gives you may not be the same kind of scalability that Aurora gives you versus what an RDS Postgres gives you. So all three will give you three different levels of scalability. It is just a matter of figuring out what your requirements are and which particular service from AWS fits the bill for you.
Okay. I think we'll move on to next topic. Aditya will answer your questions. We'll answer your questions later on. We'll move ahead with the schedule. Arti, if we can reply to Aditya's question on Zoom, that would be.
Just give me a minute. My Zoom bar has frozen. Yeah. Has my screen sharing stopped?